I'm going to get a little heady today, not cow's head. I got this shirt in Argentina recently. So, AI scaling. Let's talk about a problem in AI scaling that I think is unsolved and very difficult to solve. Um, it's about routing to the best model for a problem. Mark Benioff recently on the podcast that I hate listen to, the All In Pod. Mark Benioff is the CEO and founder of Salesforce. He said that, oh yeah, that's going to be what drives the cost of AI down, cheaper tokens because they're better routed. And obviously, you can do some token routing. But the problem is really hard when you don't know which model to use and you want to rely on AI to do the routing. I would argue that the router itself needs to be your most capable model, which kind of defeats the purpose. You're already sending all the context to your most capable model to make a decision on how to route it. It's got to think about that context and use all those tokens. Why? Why do you have to do this? Well, I can think of two reasons. One is that the best AI will know more about what you need to know than even you do. Maybe you want something, you say, can you just translate this for me? And the AI will know enough from its previous work with you and the current context that you give it, then maybe you don't just need a word for word translation like Google Translate might give you, but rather that it should translate this for you with some cultural understanding of the way people say things in business in Argentina. That's the router being really intelligent to give you the best possible answer. Um, and that's just one like kind of mediocre example because even Opus 4.5 or whatever could do a pretty good job of that. But you can imagine that goes up and up and up. That a router needs to be smarter and smarter and smarter to better understand what you're actually asking. Maybe you're asking something about geopolitics and um, it needs to give you the best possible answer because you might have some power geopolitically. Uh, anyway, that's one reason. The other reason is actually more important and easier to understand and easier to agree with, and that is threat detection. So, say you're just asking for some code to do something. A dumb model might be like, here's your code. A smart model might be like, whoa, 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 wait a minute. I can see that a person asking this particular question might be weaving together several different unrelated questions in order to create a cyber attack. That's really important to notice. And if you just skip that part and the smartest models are out there but not applied to that particular query or prompt, then you've just allowed somebody to do a cyber attack in order to save some money. It's not ideal. Um, yeah, so I'm not sure how you solve this problem. There are people working on solving this problem using something called model escalation, where a dumber model is the router and it tries to answer the prompt and it's really honest about its inability to do so, so it escalates to a higher model. But I would say those don't address like the cybersecurity issue that I brought up or the reframing issue that I brought up because the dumber model will be like, oh yeah, this is in my wheelhouse, I got this. Whereas the smarter model will have been like, oh no, hang on, this is what you really want, or this is what I won't let you do. Um, so yeah, I think what we need to do is make the smartest models cheaper, not route to the dumber models.